Right, just a real quick reminder, rundown of why the math is so important when you start dealing with different types of battery chemistry and replacing batteries, refurbishing, repurposing, whatever. Number one, get yourself a battery capacity tester, analyzer, whatever you want to call it. Okay. Important because you start putting in dead batteries in your pack's not going to work worth a shit. Trust me. Right? 1.2 volts at 1400 milliamps is the rated. The first time I tested this, 887. Second time, 1 amp. This time around, 1.4. So it's being reconditioned. These batteries came out of a pack like this in exactly this box. Rated at 10 volts, 1500 milliamps. Well, 8 times 1.2 is 9.6 at 1400. So where's the extra 0.4? Where's the extra 100? Same with this pack. 7.2 is what it should be, but it says 7.5. I replaced it with 2 lithium ions, okay? Consider them a 3.6, not a 3.7. The math works better that way. 1.2 times 3, 3.6, 3 to 1. Okay, the magic number we're after is 25.2 volts. It takes 7 of these to make a 25.2 volt pack of lithium ions. Therefore, 3 times 7, it would take 21 CADs in series to make a 25.2 volt pack. Lithium irons takes 8 in series to make a 25.2 volt pack. 4 in series of the lithium irons is swappable for a lead acid car battery. So therefore, 2 lead acid batteries make a 25.2 volt system. As you can see, the ion is 28.06 right now for a charge, and the iron is bouncing back between 7.9 and 28.0. So now I could take 21 in series. I could take 2 car batteries in series and these in series and combine them all in parallel to make one big battery because the math works out on them. But don't trust the hype, okay? Sometimes when we do our swaps, these are 3 ions in series. That gives me a 10.8. I have to take some circuitry and knock it down to get me as close as I can to roughly their recommended 10.0. Okay, so circuitry. Lithium irons in a different package. Supercapacitors with their own circuitry. Circuitry here. Okay, that's to protect your individual batteries, or at least that parallel bank, to keep them the same as the next bank. Because if they get too far out of whack, well, then eventually one goes dead. Your battery charges really fast and it drains really fast. It doesn't work right. Okay? And that's the problem with some of the old ones. They didn't have any of that circuitry. They threw in a resistor and a diode and stuff under here to help with some charge protection, but that's about it. They didn't protect each individual battery. So if you get into making your own packs, you have to get into the circuitry. Okay? Otherwise, you're going to start setting things on fire, blowing things up, and that's not good. All right? Or they'll just flat out not work properly after a while because your battery bank gets out of whack. Or you have one that says 1.5 amps and the other one says 800 milliamps, half of that, and you've got them in the same pack. Your pack will not work properly. Okay? So isolate them out, get them as close as you can to the same when you're building your packs. Okay? So anyways, that's pretty much it. Protect your batteries, monitor them, and when you get to that 25.2 volt system, you can start combining everything together. Now becomes the problem of, all right, how do I charge that? How do I distribute that power? And that's where you have to get into some of your circuitries, your boosters, your step downs, your chargers. Um, and then you talk about your inverters if you want to run AC. You know, do we want to run 12 volt battery packs? Do we want to run 25 volt? Because the 25 volt inverters are a little bit harder to find. In some cases, can be more expensive. Then you get into pure sine and modified and square and all that stuff. And what kind of circuitry are you running? What kind of equipment? Okay. But if you can repurpose old stuff, okay, you can get some used laptop batteries for fairly cheap now. New ones can still be fairly expensive. But do yourself a favor, get your capacity testers if you're dealing with old batteries or used batteries or you're not sure where they come from, and test them out and learn about the chemistry a little bit so you know how those batteries behave and they react. Lithium ions have high capacity. Lithium ions don't. They have high current draw capabilities. So therefore, when we combine those packs, we're getting the best of both worlds. Right? In theory. So, lot to learn, lot to spend on, lot to invest on protecting your investments. Okay? Not overnight, but in due time, you'll learn it, you'll acquire it, and when it needs to be in use, it will be there for you. It's pretty much that. More to it, of course, obviously, but this should give you a basic understanding. Really, if we want, let's go to that 25.2 volt system. That's really our best bet to combine all this stuff and make the best use and repurpose old stuff rather than just tossing it aside. Yeah, I've got more, I believe, on my Franken stick video. There's some of the math that I broke down on paper. So anyways, yeah, best of luck to you all. Don't burn yourself up or shock yourself.